So chapter 12 is either all definition or just using your calculator. So it can be like the easiest thing you do all year, but if you're spaced on the definitions or you don't know how to use your calculator, you're in a whole heap of trouble. So my suggestion to you guys is lock in here for today because you don't want to miss this stuff. This can be very, very easy.
Sorry.
You're fine. Let's try to make life easy, right? You know, my life's hard enough. So we're going to start just by talking about polynomial functions. So when we say something is a polynomial, it means that we can write it in a specific form. Specifically, we can write it as like a sub n times x to the n plus a sub n minus 1 to x to the n minus 1 plus yada 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 a sub 2x squared plus a sub 1x plus a sub naught. So as a piece of vocab, the a subscripts we call the coefficients. Those are all real numbers, and the a sub n is a non-zero real number. The exponents have to be non-negative and integer valued. So no negatives, no fractions, no decimals. Positive whole numbered only. And then to describe our polynomial, we use the degree, which is just going to be the biggest exponent, and the leading coefficient, which is the coefficient on the biggest exponent term. So that would be a sub n in this case. Now this looks kind of confusing at the start, but we'll do some examples here and you're going to see that, like, okay, this is pretty straightforward. Let me grab a couple of examples. All right. So here we're being asked to determine if the function is a polynomial function. And if it is, give the degree and the leading coefficient. If it's not a polynomial, makes no sense to talk about degrees and leading coefficients because those are characteristics only of polynomials. So let's look at a. F of x equals 4x to the sixth minus 5x squared plus 2x minus 1. What do we think? Is that a polynomial? Yes or no? Yeah, right? The only operations going on is like multiplication between variables and constants, and then addition and subtraction. All the exponents are positive whole numbers. I should say all the exponents on our variables anyways are positive whole numbered. So yes, that's a polynomial. What's the degree for that polynomial? The degree is the biggest exponent, 6, and the leading coefficient is it's not 5, so the leading coefficient is the coefficient on the biggest degree term. So it's 4. It's not the biggest coefficient. So we could say, yes, f of x is a degree 6 polynomial whose leading coefficient is 4. Feel okay there? So far, so good? B. So g of x is equal to the square root of x, or square root of 3 times x minus 6. Is that a polynomial? What do you think? You say no, why not? Well, isn't the square root of 3, that's just a number, right? And it's just being multiplied to the variable, right? Are the coefficients allowed to be any real number? Yeah. So is this a polynomial? Yeah, it is. What's the degree for this polynomial? 1. Very good. Where did you get the 1 from, Lucy? Yeah, well, there's always an exponent of 1 on that x, even if we didn't write it. Everybody's okay there? And then what's the leading coefficient? What's the coefficient on the x of the first term? Square root 3. H of x is the square root of 9x to the fourth plus 16x squared. Is that a polynomial? What? Did we say yes or no? Yes is incorrect. Ooh. Mr. Kulik, it looks just like A. What's the difference? What's going on in C that's not present in A or B? Yeah, so the square root extends over the variables, right? Notice in B, the square root only extends over a number. In part C, the square root extends over variables. No longer a polynomial because of that. And then D, is that a polynomial? Why not, Bella? Has a negative exponent. You got it. Remember, those exponents, though, have to be on the variables. If that's the only place we care about the exponents being positive or negative or whole numbered. Right? I could write 3 squared times x plus 5, and that's a polynomial still. Or I could write 3 to the negative 2 times x plus 5, still a polynomial, because the exponent isn't on the variable, or the negative exponent isn't on the variable. What do you guys feel like? Is that okay? Get the picture? Not too bad. Another way we can name polynomials or classify polynomials is by the is with their degree. So we can say that we have names for these. If we have a 0 function, just f of x equals 0, that's a polynomial. We say that's undefined degree. A constant function where if f of x is equal to some non-zero a, so like f of x equals 5 or f of x equals 1/2, Those are degree 0 polynomials. If we have a degree 1 polynomial like ax plus b, we say that's a linear function. If we have a polynomial, a degree 2 polynomial like ax squared plus bx plus c, we call that a quadratic function. So those are just some common names that we have for polynomials based on their degree. So in section 12.12, we're going to talk about correlation. So correlation essentially is describing the strength of the linear relationship between two variables. So to just get a feel for this initially, so if I have two variables x, y, which one of these seems like it has the stronger correlation? The first graph or the second graph? The first one. Why would you say that, Aiden? Because it just looks like a line, right? So we'd say that those two that x and y have a strong correlation. Okay. And say like we had these red dots now in addition to the black ones. Have I increased or decreased the correlation in that first picture? Decreased. Why? Because it's more spread apart. It still kind of looks like a line. There's still some good correlation there, but it looks like a thicker line, right? I need like a big fat magic marker to draw a line through that. Does everybody feel okay? So that's the idea in a nutshell of what correlation is. Now, we can do better than just looking at it with our eyeballs and talking about strong and weak correlations. We can quantify this using something called the correlation coefficient. Which we abbreviate with the letter R. So some facts about the correlation coefficient. So R is always a number between -1 and +1, and we'd say that's inclusive, like it can equal 1 or -1. If R is less than 0, that means we have a negative correlation. So our data kind of slopes downward. If R is positive, then we have a positive correlation. That means our data would slope upward. If R equals 1 or negative 1, then we have perfect correlation. Which means that all of our data points are actually points on the same line. Okay, so perfect correlation means that you can construct a line that passes through all of our data points perfectly. And if R equals 0, it means that there is no correlation. That's like these two variables have really no linear relationship between themselves at all. They should just look like a random scattering of data. So if I take a look at this scatter plot, we're asked to describe the correlation based on the graph and then give an estimate for the value for R. So if we're describing our correlation, we need to say two things. We need to either say it's positive or negative, whether it's strong, moderate or weak. Everybody's okay with that? So let's start. Is this correlation positive or negative? Negative. Why did you say that, Lucy? Because the data slopes downward. Everybody see that? Okay. Are we going to say this is strong, moderate, or weak? So we're going to describe now the strength of the relationship. Is it very strong, moderate, or weak? What do we want to say here? I would say this is closer to strong than moderate, to be honest with you. It's very clearly line-shaped. It's not that spread apart. I think you could say strong here. That's okay. And now let's estimate an R value based on this. So this is almost a pure guess, except we know one thing right away. What should the sign of this R value be? It needs to be negative because it's a negative correlation. So it has to be some number between -1 and 0. The closer we are to -1, the stronger our correlation is. The closer you are to 0, the weaker this is. I would accept an answer between -0.7 and -1. Really, any number in there would be good enough for me. So maybe I pick that. Is everybody okay there? So it's like because that's kind of the breaking point between things being strong and moderate. I would say like between 0.7 and 0.5 would be moderate, and then less than 0.5 is weak. All right. But we don't have to settle for just an estimation for these R values. We can calculate this specifically. So to do that, we're going to use our calculator. So if you have your graphing calculator with you, I invite you to take it out and follow along. If you don't have it with you, or you're just like, I can't do this today, Mr. Kulik, I'm out, I would recommend that when you get home and are feeling more motivated, you take a minute and run through this yourself so that you get a handle on the procedure here. All right, so what we're going to do first is something we should only have to do one time unless our calculator's memory is reset. Okay, so we need to turn the diagnostic for our calculator on so that the R value will display for us. To do that, we're going to go into the catalog. So we're going to press the blue second button and then the 0 command. That's going to open up the catalog. The catalog contains every command on our calculator listed in alphabetical order. The command we are searching for is called diagnostic on. So I could scroll with the arrows, but I don't want to do that because there's a lot of letters in between A and D. If you notice on your calculator screen on your keyboard, there's little green letters. So I'm going to press the one with the D. So that's the X to the -1 button. That skips me all the way to the D's in my catalog. And now I'm going to scroll down and look for diagnostic on. Those of you following along, have you gotten here? Okay, I'm going to press enter. That pastes diagnostic on onto my home screen. I'm going to press enter again so that it says done. Now the R values will display for me whenever I do a regression. If your calculator memory is reset, you'd have to redo this process for it to display the R values once again. Everybody's good? Okay. What I'm going to do first is I'm going to enter this data into my calculator. To do that, I'm going to press the Stat button there in the middle of my screen. And I'm going to pick from the Edit tab, the Edit command. So what I'm given here, L1, L2, L3, these correspond to lists on my calculator. I'm going to enter these prices in L1 and these quantities in L2. Now I already have a bunch of gobbledygook in here, so I'm going to get rid of that stuff. To get rid of an entire list, you can delete items one at a time by pressing the delete key. Or I can clear the whole list by moving my cursor so it's on the list title, pressing the clear button, not delete, and then the down arrow. So I press clear and then down, and it'll wipe the whole list for me. So I can delete individual items using the delete key, or I can clear the whole list by highlighting the list name and pressing the clear button. Like, whoop, all gone. All right, so into L1, I'm going to type these prices. So I'm just going to type the number and press enter. And then I'm going to go over to L2 and enter in these quantities. Those of you following along, have you had a chance to enter in this data into your calculator? Great. So I'm going to exit out of here. And I guess before I calculate this R value, let's look at the scatter plot of this data. We can make an estimate ourselves. Sound good? So to create a scatter plot of our data, I'm going to press second. That's the blue button. And the Y equals button. That is going to open up the stat plot menu. We have the option to plot up to 3 scatter plots at a time. It doesn't matter which one you choose. I'm going to just pick plot 1. I'm going to begin by turning it on, so by pressing enter. And then I want the first type option, that's the scatter plot option. Now remember when we typed in our data, I typed my data into L1 and then L2. So here where it says list X list and Y list, I want to make sure it says L1 and L2. If it doesn't, notice in blue above the numbers 1, 2, 3, 4, 5, 6 are the L1, L2, L3, L4, L5, L6. So if I needed this to be, say, L5, I can press second and the number 5. That would allow me to change those. But I don't want to do that because I typed my X's into L1. So everybody, so far so good? Okay. So everything is set. The mark I like to use is the square because it's easiest to see on my calculator. And what I'm going to do now is I want to graph the scatter plot. To graph the scatter plot, the easiest way to do that is press the zoom button. Oops, because we got to exit out first. And then press the zoom button. And what I want to do is pick Z or zoom stat. Sorry, so that's command 9 in the zoom menu. And there's my scatter plot. If you had some other lines and stuff showing up, it's because you had stuff in the Y equals menu. I probably should get rid of that. You can clear those out of there and it'll just be the clean scatter plot. Any questions so far? If we were to estimate an R value for this, what would we say? Negative 0.9 maybe? Looks pretty line-like to me. What do you guys say? Yeah? All right, let's have the calculator actually compute that R value for us now. So I'm going to press second in the mode button to exit out of here. I'm going to go back to that stat button. But this time I'm going to go over to the calc tab. That's short for calculate. And I'm going to pick the option that says linreg. So my calculator opens up a menu that looks like this. Some of you, it might just paste linreg on the screen. So if you just have the linreg pasted on the screen, I'll be with you in a second. Actually, does anybody have that? Or does everybody have a menu? Everybody got a menu? When you did this? Yes? Okay. So just like before, we typed our X data into L1, our Y data into L2, so that's fine. We will never in this class use a frequency list. That will always be blank for us. And then we have the option store reg EQ. This is one that I am going to take advantage of here. So I am going to store this equation that we're about ready to make. And the place I want to store it into is one of the Y equals slots. So I can graph this and compare this line to my data. Is everybody okay with that plan? So what I need to put here is the Y1. To get the Y1, I'm going to press the vars button, which is right under the down arrow. I need to go over to the YVars tab, pick the function option, and then I'm going to pick Y1. So now next to store reg EQ, it says Y1. And then I'm going to hit calculate. So up at the top, it tells me the type of equation I wrote. I wrote a Y equals AX plus B. That's like a slope-intercept equation, right, guys? It tells me the value for A is negative 101.64, negative 104.685, yada, yada, yada. And then the B, it tells me, is 329.28, yada, yada, yada. The R squared, we haven't talked about what R squared is. Give me a minute and we'll get there. But the R value is negative 0.96, yada, yada, yada. So our estimate of negative 0.9 was pretty good, right? Everybody's okay? If I hit graph now, well, actually, before I hit, let's hit Y equals. Notice that in Y1, the calculator has automatically inputted that equation it just showed me. So it's all there. I didn't have to type it in or nothing. It did it for me automatically. That's really nice. Thank you, calculator. That's what the store regeq does, is it types that all in there for you so you don't have to copy it yourself. If I hit the graph button now and I look, this is like a line of best fit. So this is the line that passes through or passes as close to as possible as many of the points as possible, or is as close to possible to all points in my data. Everybody's cool with that? Now you might ask, why would I want to do something like this? Well, this is actually like one of the most practically important things in mathematics that we get a chance to do. What we're essentially done here is we've created a model based on the data for this situation. Assuming that this situation, where we're pricing some cans a pop or something and we're looking at the number of cans sold, we can use this to make a prediction. Say, for example, I wanted to predict how many cans I would sell if I charged 50 cents a can. Right? So what I'm going to be doing is I'm basically going to be plugging 50 in for the x into that equation that we just created. But I'm not going to do that by hand. I'm going to let the calculator do that for me. Because the equation to describe this situation is in the y1 spot already, all I need to do is use some function notation with my calculator, and it'll plug the 50 in for me. Yes, sure. So I'm going to press the vars button. Actually, I'm going to retrieve the y1 command is what I'm going to do. So I'm going to press vars. I'm going to go to yvars. I'm going to pick function, and pick y1, and I'm going to do like a function notation where I'm going to do y1 of 50, and then press enter. So what that's doing is it's plugging 50 into the equation here into y1. Which is not what it did. Why did it not do that? Oh, it's because that's $50, right? I plugged in $50. I said 50 cents. What should I have typed in for 50 cents? 0.50. Oh, good golly, Miss Molly, that makes a lot more sense. So if I charged 50 cents, I'd sell about 277 cans of soda pop or whatever this is. That would be my prediction. What if I wanted to try to figure out the price I should charge to sell 50 cans? So remember, X is the price, right? So what I want to do here, if I'm looking for an X, I'm going to type the desired Y into like Y2. And then I'm going to hit graph. Now, nothing showed up, right? What's the problem? It's going to be the window of my calculator is inadequate. If I press the window button, this is describing the values for X. And this is describing the values of Y that I can see. Look at the Y minimum. 58. That's the smallest Y on my Y-axis. Am I going to be able to see 50? No way, man. I need to change that Y minimum so that I can see 50. I'm just going to change it to 0. If I hit graph now, There comes my line. Woo! I can't tell if they're crossing or not. Can you tell? Looks like they might be, but they might not be. If they're not crossing, my calculator won't find the intersection. So I'm just going to scoot the graph over to the right. So I'm going to change the x max to, say, 3. I'm just going to make it a little bigger. And then I should have plenty on there. Look at that. Nice intersection right there. To find this intersection using my calculator, I'm going to press the second button. That's the blue one. And then the trace. I'm going to pick the intersect command. And then because there's only 2 lines graphed and they only have one intersection, I can just press enter 3 times. So it tells me the price that I'd want to charge to sell only 50 cans a pop would be like $2.67. So you guys feel okay there? Mm-hmm.
I do like 2 steps ago. I get the line. I think I did it right, but
Oh, the horizontal line?
yeah.
I just typed 50 into like y2 and the y equals.
Oh, okay.
So if I'm trying to find an x, I need to put the y value into the y equals and find the intersection. If I'm trying to find a y, I'm going to do like y1 of whatever the x is. Does that feel okay?
Yeah.
Okay.
Can I please use the restroom?
Sure. Absolutely. Now, what we've just done here is we created a linear model for this situation, but that's not the only shape that your data might take, right? Like if your scatter plot looks like this, well, that looks like a line that's going to be linear. But what if my data looked like this? What shape is that? Looks like a parabola, right? That's quadratic relationship. Or what if my data looked like that? That's like a cubic relationship. Or maybe my data looks like this. That's exponential. Or what if my data, looked like this? It's like a power or maybe a log. So we need if I tried to calculate an R value for any of these, they're going to be El Garbaggio, other than the linear one, because these things don't look much like lines. But maybe one of these other models would be a really good fit. So what we'll use is called the coefficient of determination. Which we symbolize with an R squared. And what it does is it basically describes and that describes how good the data fits a not necessarily linear model. So if I'm comparing like a quadratic and a exponential model or something, I can look at the R squared values to decide which one of those is really the better fit for my data. Because sometimes if I have just like a piece of an exponential or a piece of a quadratic, they look really the same, right? So let's do that for a moment. Oh, actually, before we do that, if we look at these guys, these different shapes that I gave you guys, the one that we're probably not familiar with is this power function, right? Is that something you guys remember talking about in Algebra 2? Probably not, right? You probably didn't. Let's define what that is, actually, before we get going. And then we'll go do an example of doing this fitting. So a power function is something where f of x is equal to k times a to the x, where k and a are both non-zero. We call k the constant of variation or the constant of proportion. And we call a the power. So if we would say in words, oops, that's not at all where I thought that was going to get put, that the f of x varies with the 8th power of x. So if we take this and kind of apply this to another situation, here my variables are like talking about the volume of a sphere. Yes, sure. Are like r and v, where r is like my independent variable and v is like my dependent variable. So we would say that this is v varies with the 3rd power of r, where a is 3 and k is 4/3 pi. Is everybody okay with what we mean by a power function? Again, it's just like a definition. Yes, go ahead. All right. So let's do another example. All right. So consider the table. We're going to create a scatter plot and then create a power regression curve. Notice it tells me in the question what type of model to make to model the data, and then use that curve to estimate the orbital period of Neptune, which is 4,470 or 497 gigameters from the sun. So what's my first step going to be? I got to enter this data into my calculator. Where do I go to do that? I press Stat. from the Edit tab, I pick the Edit command. I'm going to clear out the data in L1 and L2, so I'm going to move my cursor to L1. Press the clear button and then press down. I'll do the same thing for L2. And then I'll type those distances into L1 and those periods into L2. Who's figured out what orbital period really means? It's like the length of a year on that planet, right? Earth's is 365.2. That's the length of a year, 365 days. What's the 0.2? That's, yeah, you get 5 of those and you've added up in 1 extra day. That's our leap year. That's why we have a leap year. Everybody's good? Got the data entered, or do you need a minute still? There's a question you could answer if you're still typing. Okay. So I'm going to exit out of here now. To create the scatter plot, I'm going to go to the stat plot, so secant and y equals. I'm going to pick plot 1. Make sure it's on. L1 and L2 are my lists that I'm using. I'm marking with the square. That all looks good. I'll exit out of here and I'll press zoom stat. So there's my graph. Great. Sure, whatever. So that's the scatter plot. Oop, we did that. Now wants a power regression curve. So I'm going to exit out of here. I'm going to go press the stat button. But this time I'm going to go to the calc tab. And I'm going to scroll down amongst all of my different regressions. I'm going to look for power regression, PWR-REG, that's power regression. I'll press enter there. I want to use L1 and L2. That looks good. I'm going to store this into Y1, though, so that I can use it later on because it asks us to do something with that. So to get the Y1 there, I'm going to press the vars button. I'm going to go over to the YVARS tab, pick the function option, and pick Y1. And now I'll press calculate. So here's my equation. I'd say my answer is y equals 0.2001 times x to the 1.4996 or whatever. Like I would tell you in the problem how many decimal points I wanted rounded to. Probably a lot of them though. Okay, so there's our model. We did that part. Says, then use that curve to estimate the orbital period of Neptune, which is 4,407 gigameters from the sun. Okay? So what I'm going to do is I'm going to do y1 of 4497. And I know I need to do that because these were my x's. Those were my distances from the sun. So I know I'm plugging it in for x. So to get the y1 again, I'm going to go vars, yvars, function, y1, and I'm going to do then in parentheses 4497. So the calculator is going to plug 4497 into whatever the equation is in Y1. So I get 60,150.1 for the orbital period. So that's the estimate part. Does that feel okay? All right. Last topic. Yes, sure. Okay, how can I tell if I've made a good or bad prediction? Right, like I just made an estimate of the orbital period for Neptune, right? Guessed at how long it should take to go around the sun. But how do I know if I've done a good or bad job? So there's two things I'd want to, or things that I'd want to check. Maybe I should say, is the model a good fit for the data? So if I went back, notice the R squared value here is outstanding, right? Definitely got it. Everybody good? Okay. The next thing I'd want to check is to see if I'm doing extrapolation or interpolation. Do you guys recognize these two words? Extrapolation is the bad one. Interpolation is the good one. So extrapolation is where you're making a prediction for x's that fit far outside of your data set. So if I'm picking x's that are bigger than 1,427 or smaller than 57.9, I'm doing extrapolation. If I'm picking an x in between, I'm doing interpolation. Is everybody okay with what I mean by extrapolation or interpolation? Why is extrapolation not to be trusted? Well, if we go back to our linear model for the cans, remember the cans? Remember when I accidentally typed in 50 instead of 50, or $50 instead of 50 cents? What kind of number came out? Was it negative 4,000 or something? Does that make any sense that I'm selling negative cans? Nope. You know why? That relationship, although looked linear based on the little snippet that I had, probably isn't actually linear because you can't sell negative cans. Eventually you just sell zero and it stays at zero. And if I charged negative dollars for the cans, it would give me still a positive value of cans, right? If I'm paying you to take the soda pop, but like who wouldn't take a can of soda pop if they're being paid? Right? It's like, here's $5, take this can. Who would say no? No one would, right? So like, that's why extrapolation is troublesome. And the last thing you'd want to consider is that source data biased in some way. So here's an example. Let's say I went and measured went to like 5 local high schools, and I recorded the heights for the boys basketball team. And I used that height to make a model to predict the heights for, 10th graders. Is this going to be a good model? No, what's the bias? If you're a boy basketball player, you're probably much taller than average, right? So I used like a data set that was biased in some way. Everybody's okay with what I mean by that? Okay. This is essentially chapter 12. We did all of chapter 12 in one day. Oh my gosh, Mr. Kulik, you're kidding me. No, man. Like, it's knowing definitions and like using your calculator. At this point, you guys should be able to do 1 through 31. Now you're like, that's 31 problems, Mr. Kulik. All you're doing for most of them is just typing the data in your calculator and getting the model to come out. Lucy says it's too much. It'll be okay. Yes. I'm assigning all of this because I know that you need to practice using your calculator to do this. Because once and twice is probably not enough times to practice this. You got to do it. So you remember where the buttons are, where the menus are, how to navigate your calculator. So just as a heads up, next class, what should you expect to see? Homework quiz, because guess what else we're doing that class? The review and building our half sheet, because the class after that's going to be the test. Yeah, it's a 1 day. This will either be the easiest test you ever take or the worst test you ever take, depending on how comfortable you are operating your calculator. Sure.